Okay, this screencast will cover some of the checking of your understanding from physicsclassroom.com based on electric field intensity and the electric field patterns. And the first one, it's using the idea that the electric field is based on K, which is a constant, doesn't change, Q, which is the amount of charge that creates the field, so it's the source charge, and then the distance squared that you are from the center of that source charge Q. So the first set we have is that um, when measured 30 centimeters away, the E, electric field, is 40 newtons per coulomb. So 40 newtons per coulomb when 30 centimeters away from a charge Q. Now, the first one asks what happens if we go 60 centimeters. Now, 60 is going to double the distance, but again, it's inverse square. So if we put a 2 in front of that, the distance, we have to square that. So it's going to be 1/4 as much. So 40 divided by 4 is going to be 10 newtons per coulomb. If we go 15 centimeters away, we're then 1/2 of the distance. I have to square 1/2, that's 1/4. When you divide by 1/4, it's the same as multiplying by 4. So it's going to be 4 times more. So 40 multiplied by 4, which is 160 newtons per coulomb. If we go 90 centimeters away, that's 3 times further than the original. So put 3 out here. Again, we got to square that, so it's going to be a 9 times difference. And since we're increasing the distance, that's 1/9 as much. So it's going to be 40 over 9. And that's newtons per coulomb. Now, if it's 3 centimeters away, that's 1/10 of the distance. Now, you got to square that. 1/10 squared is 1 over 100. Dividing by 1 over 100 is the same as multiplying by 100. So it's going to be 100 times more. So we're going to go from 40 to 4,000 newtons per coulomb. Okay, 2 zeros more. Big difference. We're really in close. When you're in that close, you're going to have a very large electric field strength. Then 45 centimeters away, we are at a distance that is 1.5 times the original. So then you have to square that number. Okay, so that's going to be 2.25 times more. 2.25 times 40 is going to give us 90 newtons per coulomb. Sorry, it's 1 divided by, so it's an inverse square, sorry. So 40 divided by 2.25. So we're going to be down to about 18 newtons per coulomb. Okay, so again, it's inverse square. That's the same as gravity was. It's the same as little g is. It's the same as the concept of Coulomb's law. It's a tougher one, but an important one. Okay, now this time we have the same setup, but now we're not changing the distance, we're changing the charge. So it's again, the electric field strength is based on K, Q over the distance squared. Now we're not going to change this at all. We're just going to put a different number in front of the Q. So if we double the Q and put a 2 up here, that's the same as multiplying the whole thing by 2. So we're going to go to 80 newtons per coulomb. If we keep it 30 centimeters away and we change it to 3Q, then it's going to be put a 3 in front. 3 times 40, that's going to be 120 newtons per coulomb. So whatever factor you change the charge by, that's going to do exactly the same amount to the force, to the electric field strength. Now, if we double or change both the distance and the charge, then we have to look at both impacts. So in C here, we're doubling the distance, so that's going to be 2 times the distance, but we have to square that, so it's going to be 1/4. And at the same time, we're doubling the charge. So that's going to be an overall impact of 2 and an increase. So 2 over 4 is an overall change of 1/2. So it'll be 1/2 as much, it'll go down to 20 newtons per coulomb. Now 15 centimeters away, we've cut the force in half, which is going to give us 4 times more electric field strength. And at the same time, we've also increased the charge. Twice as much charge is going to give us 2 more. So we're going to have a 4 times increase and a 2 times increase. 4 times 2, it's going to be 8 times more than it was. 8 times 4, that's going to be 320 newtons per coulomb. Now 150 centimeters away, that's a 5 times increase of distance So that's 1/25th as much of electric field strength. And then we are also reducing and cutting in half the charge. So that's a half as much charge. So the overall effect is going to be 1/50. So that's going to be 40/50, which is 4/5 of a Newton per Coulomb. Okay, so again, we've done this over and over again, but it is a tough pattern to get the first few times through. But it is a very common pattern in nature, the inverse square pattern. So you should become very familiar with it.